All right, this is for Cole, who is absent again, unfortunately, but I'm sure he's watching this video because he really wants to get caught up in his reachbacks and make sure all of this math that he's supposed to know is still attainable. So we have 9 questions here, reachbacks to all of the things we've learned so far this year. The first question says 3/4 multiplied by 5. Now there's 2 ways you could solve this. Now the inefficient way is to actually draw 3/4, right? And then draw it 5 times and then count the number of quarters. That would be crazy because you'd have to be insane to do it that way. Another way to say it is if you have 3/4 and you multiply it by 5, how many quarters do you have? Well, you'd have 15 quarters. That's another way to do it, just kind of contextualizing the question. But from an algorithm or just a procedural standpoint, if you consider the whole number to be a fraction over 1, and you multiply the numerators, and you multiply the denominators, you get 15 quarters, which in itself is the correct answer, but it's an improper fraction. And if you left it as an improper fraction, you know, people in the mathematical community would think you're insane, but you'd have 3 3/4 as a final answer as a mixed fraction. The second question says 4/5 divided into groups of halves. Now remember when we actually studied this, we said, well, let's think about it in terms of money. So if we think about it without really doing the question, I have 4/5 of $1.80 divided into piles of 50 cents. Let's think about that for a second. Let's estimate. If you have 80 cents and you're dividing it into piles of 50 cents, can you make a pile? Yes. Can you make 2 piles? No. So you know before we actually start doing this question, your answer should be 1 something, right? Somewhere between 1 and 2. So that's without doing any math. We're just thinking of the question in terms of what does it mean. So we know our answer is going to be 1 something. And then we're going to actually do the process to get the answer. And we know the easiest way to do it. Now you could find a common denominator, make them into equivalent fractions, divide the numerators, divide the denominators. When we divide the denominators, our answer will be 1 because it'll be the same denominator. And our answer will be simply the division of the numerators. But we said that's not the easiest way to do it. The easiest way to do it is to keep your first fraction and multiply by the reciprocal or the flip of the second fraction. That's the easiest algorithm to get the answer. And when we do that, we multiply our numerators to get 8, multiply our denominators to get 5. That's an improper fraction. Your final answer would be 1 3/5, which works well with our estimation of 1 something, right? If you have 80 cents divided into piles of 50 cents, you'd have 1 and a bit more piles. Our third question is a BEDMAS question. It has an addition and it has a division. And we know that when we do this, we're supposed to do our division first according to BEDMAS. So again, whole numbers thought of as being over 1. It's division, which means really what I'm going to do is multiply by the reciprocal of 3. And what's the reciprocal of 3? That's a third. So when we do that, we really have 2/3 multiplied by the reciprocal, which is 1/3. Multiply the numerators, multiply the denominators. 2 times 1 is 2, 3 times 3 is 9. So the answer for this is 2, oh, it's the world's worst 2. 2/9 is the quotient for that particular part. Bring down the rest, 1 over 2 plus 2 over 9. Now your brains have to transition from how do I multiply and divide fractions to how do I add and subtract fractions. When we add and subtract, it's a grade 7 outcome. We need to find a common denominator. We have 18 as our common denominator. Our equivalent fraction, 1/2 is equal to how many 18ths? Well, we know that it's 9, but if you didn't know that, 2 times 9 is 18, 1 times 9 is 9. 2/9 is how many 18ths? Well, we multiplied that by 2, so we multiply that by 2. We get 4. Now we're on the home stretch. Now we have an addition of 2 fractions that have a common denominator. Add our numerators, we get 13. Keep our denominator, we get 18. And our final answer is 13/18. Now we transition to the second line, which is all algebra questions. In this particular one, we have a constant of -5, and we have a coefficient of -2. I don't know why that's delaying so much. What happened there? There we go. So when we have a constant and a coefficient, z, what are we supposed to get rid of first? Right. So what am I going to do to both sides? That's right. We're going to add 5 to both sides because our constant is -5. So by adding 5 to both sides in this equation, remember an equation is a balance of 2 sides. So whatever I do to one side, as long as I do the same thing to the other side, life will be good. I now have a negative 2x equals 6. And once I have this, what am I going to do to both sides, jellyfish? Correct. I'm going to divide both sides by negative 2. And I'll get x is equal to negative 3. Perfect. Now, in the next question, Hunter, we also have a two-step algebraic question. What's my constant? What's my coefficient? No, it's not negative 2, Hunter. No, it's not negative 2. Dima Ely, what's the coefficient in this particular equation? Negative a half, right? How much of x do we have? We don't have half of x, do we? We have a negative half of x, so that's our coefficient. So the first thing we're going to do is we're going to add 3 to both sides to get rid of our constant. We have a negative half of x is equal to 3. We're then going to get rid of that negative half coefficient by multiplying by negative 2. And x will equal negative 6. And in our last algebra question, we have a distributive property question. We have two groups of x minus 5. It's equal to negative 30. Now, when we got to this, we learned that there were two ways to isolate the variable. First way we could do to both sides, what could we do to both sides? First, the easiest way we decided. Divide both sides by 2. Because if we do that, instead of saying two groups of x minus 5 is equal to negative 30, we'll say one group of x minus 5 is equal to negative 15. That's one way we could do it. The other way we could do it, Andrew, is to do what? These little arrows here, right? What's that called? Expand using distributive property. Yeah. And if we did that, 2 times x is 2x, and 2 times negative 5 is negative 10. And we would get this beautiful two-step algebraic equation that we could solve pretty simple, because it's actually very similar to this one over here. It's just no negative coefficient, really. And if we did that, we would add 10 to both sides. And get 2x equals, what's negative 30 and positive 15 make? Negative 15. Did I make a mistake here? Oh, that's 10, that's why. I can't read my own handwriting. Negative 20. My board's gone wonky. So I can't show you what to do because over on that end of the board it's gone crazy. But divide both sides by 2 and x will equal negative 10, right? See? Right. Some of my students are just waking up this morning. They're not quite with me. But I know they're here in spirit. Next question, negative 5 plus, I'm going to multiply first, 3 times negative 2, which is negative 6. Add those together, you get negative 11. Our next question, our 8th question, is a proportional reasoning question or a unit rate question, depending how you solved it. Most of you solved it with algebra because you're lazy. But if 4 units of something cost $2.80, the one unit, the way I wanted everyone to solve it, the practical way, is to say if 4 of them cost $2.80, what does one of them cost? How much would one be? So what we do here is we would divide both terms by 4. And that would be $1.40. What's half of $1.40? It'd be 70 cents for one. And if it was 70 cents for one, I would multiply both by 7. And I would figure out that it is $4.90 for 7. Oh, that's really terrible. But you get the idea. So the answer is x is $4.90. Most of you probably used algebra, right? Most of you probably multiplied across here and got 4x and multiplied across here and got, what's that, $19.60. Then divided both sides by 4 and you got the answers too. Either way, the answer is supposed to say $4.90 if I could write, but I can't. And our last question is what we're currently working on. How many of you solved it with a calculator? Good. If you used a calculator, 1% is a decimal. Is 0 decimal, 0, 1. Oh, God. That's 1%. 1.5% is 0.015. Just pretend I could write properly. And you're going to multiply that by 300. And if you take 0.01, that's 1%, 1.5% that, and multiply it by 300, you get $4.50. Otherwise, if you did mental math, how do you get 1% of a number mentally? Move the decimal twice, that would be $3. Half a percent is what in relation? It's half of 1%, that would be $1.50. Put $3 and $1.50 together, you get $4.50.